Right. Thanks, Jay. Maybe just add one note. I do believe everyone can actually unmute yourself if in case you wanna just jump in and share notes. Yeah, so it's a great pleasure to have Professor Stefano Giordano with us today. Actually, I met him a few months ago through the introduction of another colleague from UT Dallas. Happy to see the exciting work he has been leading in Europe, Italy in particular. I would just do a very quick intro and then I'll give the floor to Professor Stefano so that we get to hear his wonderful work there. So Professor Stefano is currently a professor at University of Pisa, Italy. He has been there, I believe, since 1994, and he's been leading the lab on telecommunications and networking systems. I think unlike probably a typical academic researcher, his team has been looking at, besides technology questions, but also with a sharp focus on its impact on society. In particular, for example, in today, we would be able to hear their work related to networking for agriculture, rural communities in general. So Professor Stefano has also been very active in the community. He is currently the chair of the Italian chapter of both the IEEE ComSoc Society and also the Internet Society. And he's also president of the board of the Qubit Lab consortium that's working on IoT and cyber-physical systems. Professor Stefano has also been actually active in education services and effort. He's currently serving on the Educational Services Board of IEEE ComSoc Society. So I guess with that, Professor Stefano, please take it from here.
Thank you very much, Hongwei, for your kind introduction. This is a very heavy slide for as an initial one, but I wanted to give credits to the projects that in Italy are supporting us in this domain. And, we had a lot of support from this recovery and resilience action of the European Union that had an action that is a restart on the future of telecommunication, an action on the National Center for Technologies in Agriculture, that is Agritech, and an action of innovation ecosystems. Particularly, we are participating as a CNIT, the Italian National Inter-University Consortium for Telecommunication, to one of the spoke to this AgriVet action in Sardinia. So thank you very much. The title of the talk is Experiences on the Integration of Computing and Communication in the Rural Areas. And indeed, my department is strongly motivated in the direction of Society 5.0. And it was before awarded in this cross-lab project in the field of Industry 4.0. Now we are thinking about our human-centered technology for the future. So the action that we want to bring in that direction, and the pillars of our activities are trustworthy artificial and embodied intelligence, human-centric system, future network, and smart materials and devices. And in this picture, I emphasize the difficulties that we have to move from just research, paperwork, etc., to innovation, which means bringing from the idea some value and in some way moving to the second part of this bridge, that is, from research moving to the market. And it's quite difficult usually for research groups to arrive to TRL7. That you notice is demonstration of a system prototype in an operational environment. So knowing that this is the most difficult aspect, just to give you an example, on 100 registered patents, only 5 will become a product. So really, we have a lot of ideas for basic research, usually for lower TRL, but when you want to move to the market, to innovation, to products, and to this demonstration in operational environment, this is usually very, very difficult. So Society 5.0 for us is something very, very difficult, very new. I don't like the word Enterprise 5.0 transformation. I like the word conversion, since in my opinion, it's a switching toward a change. And a change that takes into account this human-centric approach that is usually very, very complicated, very far away from the typical subject that the School of Engineering are covering. So we have for sure sustainability, but also resilience, as you see there, and this idea of human-centered cyber-physical systems. So you know that, for instance, in Industry 4.0, hyperconnectivity is a term that in a very, very simple way emphasizes the transformation. So it's not just doing something better, it's changing the way, okay? And of course, in this case, there is the superimposition of two transformations, the one that is digitalization and the one that is the green. The transformation that take into account not only the economical aspects, the performance aspects, but also sustainability at the social level and at the environmental level. This is something very, very relevant, and we have the superimposition of the two processes that we want to cover together. So, in my opinion, when we say that is a human-centric approach, I think it's good to emphasize that our is not only the information society, but is the knowledge and information society. So knowledge is at the center, know-how it is at the center. And if we want to bring know-how at the center, we could think again about something that is a new form of humanism, and such as the transformation that we have in Tuscany. We had in Tuscany in the past for Renaissance. So there was a totally different way of thinking about solutions such as the architecture that you see there, or some form of arts. So I'm very pleased to talk with you that are so involved in the rural areas aspect, the application of ICT and telecommunication in the rural areas. You notice that although it is not so easy to define what is rural and what is urban, there is a sort of rural-urban continuum. We know that the mega trends are towards the idea of having more and more people in the urban or even metropolitan areas. But in countries such as Europe or even Italy, the people that live in areas that are not urban, not metropolitan, are more than the one that lives in a rural area. So, for instance, in Europe, 83% of the territory is rural, and 137 million of people lives in these rural areas. So although there is this mega trend, it's very relevant to operate also for the rural aspect, the rural territory. And you notice the European Union is working a lot in that direction, considering this action that has a relationship with the resilience, with the empowering of the community, connectivity that is very relevant and related to our subject, although there is also transportation that is very relevant, prosperous, and of course, there are many other aspects behind this word, such as food security, leaving no one and no place behind, strategic autonomy, adaptation to climate change, preservation of natural resources, labor shortage. So we have to contrast in some way this situation where people are escaping from the rural areas toward the town, since they cannot be able to find labor in their territory. So this is something that for us is an opportunity to demonstrate that the application of ICT technologies are relevant, have an effect, an impact in this domain. And I want to emphasize that we don't have any generalism there. We have to know the domains where we want to act on if we want to have an impact. This idea of having a simple general solutions such as the ones that we have for consumer computer science, consumer informatics, consumer electronics is not enough. We have to know in details the problem of each of these different sectors. For instance, healthcare, education, transportation, manufacturing, they are totally different. So the value is not in being generalist. There is no one size fits all solution. You need to know the needs of the requirements of each domain to be effective and to have an impact. So, as you know, usually there is this convincement that IoT is something where there are some embedded systems that can interact with the real world, with the sensor, actuator. There is an interaction to the cloud that is mediated by the usually by telecommunications. So telecommunication here are seen just as postmen of bits. On the contrary, there are new paradigm shifts in this picture that are related to the fact that the network became a distributed cloud. We have in-network processing. So this idea of bringing your data, raw data to the cloud, where they are processed and where knowledge is extracted, of course, is something that is totally absurd, or even with respect to power consumption, to reliability, to security, to a lot of different aspects. Although even in Europe, there is a very strong action on agriculture of data, where this concept of data spaces is introduced, and this is very relevant. And of course, we have to consider this possibility, but with in mind an infrastructure that is able to provide storage, computing, communication, and in the near future, even sensing in an integrated way. So we know now that the raw data has no value, and that we want to extract information, knowledge from, a lot of experience from the past, and even wisdom from our data. So this is something that will not happen only in the remote data center, in the big data center, but in the cloud continuum that we want to realize. And of course, yes, the value is in your ideas, in the new services, is in the knowledge of the domain, in the solution that you want to provide, but the cost will be in the management. It is not something that works just do it and it works. This is something that needs a lot of effort in monitoring, reporting, observation, controlling, and of course there will be more and more automation in the future in our domains, but this is the most relevant aspect if we want to obtain mature solution with respect to this consumerization of ICT that probably missed a lot of value, a lot of impact in many, many different domains. So we know very well that it will be an internet of data center. The network will become a wide area cloud, but not only with big data centers. We will have macro data center, but also micro, pico, femto. So we needed to have in mind the capability of processing in a different parts of the infrastructure, and it would be more correct to think about the processing going toward the user instead of the data going within a centralized data center very far away from us, at least for the control loops that will be so relevant for us and for the services of the future. We will speak about this. As you notice, although it's always a question of functions, not only on performances. Speaking about the bit performances, the postman of bit aspect is not enough. We have to keep in mind the processing capability, the functioning, even the multicasting, point to multipoint, multipoint to point, the function that I can have in the network are even more relevant than just the performances that, of course, were very much emphasized in the development of 5G and 6G. Performances for what? If you don't know the needs, if you don't know the real requirements, why you are asking 1 millisecond of latency? For what? Yeah, it's a very nice the comment of my friend's Professor Franz Fixted, that very elegant guy in the picture with white clothes. I'm taking care of his dog, as you know. but nevertheless, you notice that there are contribution of delay that are related to the sensor, the physical sensor, to the embedded system you are using, to the physical transmission of information in wireless or in fiber optics communication. Then there is a strong contribution of processing in the data center and back in the other direction. So you notice when you say 1 milliseconds, we need to emphasize for what, which are the requirements, which are the requests that needs, your knowledge of which are the experiences that ask for these specific delays, for instance. And Frank is responsible of the 6G Life Hub in Germany, working one of the 4 6G hub in Germany. Nevertheless, you notice even for the definition of 6G, we need to present the spring flower, since it is the knowledge of the use case that asks for some requirements, functional and performance requirements. It's not only a question of just performances. And you notice you have to speak about merged reality, robot navigation, Earth monitoring, cobots. There is this presence of artificial intelligence, ubiquitous artificial intelligence. We are speaking about AI for net, the artificial intelligence for the inner function of the networks, but of course, more and more, the net for AI and the enabling of new AI application thanks to the new capability and function of the network. So this will be the future of 6G. And of course, some of the aspects that in the past were the definition of 5G now will be expanded with in mind, for instance, integrated communication and sensing, terrestrial, not terrestrial network integration, and artificial intelligence as a new tool that we can use inside the network and over the network. So although these aspects are so relevant, we need to keep in mind that the novelty is on the human-centric approach. So although we in the past we were speaking about connecting people and things, now we have to work about the connected intelligence, but with this immersive communication, cognition that have in mind, the concept, for instance, of digital twins, of the human-centric aspect that we have to refine with the real experiences. So all of us knows that, for instance, and particularly your group knows that we have a disaggregated possibility, for instance, with the Open RAN solution that are open source, that can run in data center in the backstage of the very big data centers, but also on premises data center, such as the one that here is mentioned as the one of University of Pisa, or someone that is very close to you, or even at the edge, such as in this situation. And you notice the front-hauling, mid-hauling, back-hauling that is composing this cooperation in processing, in communication, in storage, that is behind the idea of a 5G that is becoming open source. I like this picture that we usually say it's just COTS, consumer of the shelf. You can have Open RAN in your traditional general purpose machines, but you notice there are some more exotic components, such as the remote radio unit, and they receive usually Ethernet frames and produce the signal of, for instance, of a new radio of 5G. But there is also an issue of timing. You notice, for instance, here the synchronization plane that is relevant, particularly if you consider complicated scenario of action of these networks, of these cellular mobile networks. So in my opinion, this will happen, and it will be no more possible that we have a silos solution with components from ZTE, Huawei, Nokia, Siemens, Ericsson. Finish. I mentioned all of them, particularly all over the world, and of course they know very well that there will be this emergence of softwareization, of network function virtualization, that are the two paradigm shifts that, again, with respect to the functions, not only to the performances, are behind the transformation of telecommunication. And we know very well that there is not only the horizontal disaggregation, but this vertical disaggregation, where we dream about slicing, probably since 10 years ago. We want to be able to provide a mobile cellular network that gives you virtual function, virtual network function, together with the communication function, even in the RAN, that are sliceable, that are isolated, that are perfect for every single service. This is something that is behind the definition of 5G, and we need to demonstrate, if we want to convince people that there is something different in the evolution of telecommunication with respect to the past. So here you notice the slice for autonomous driving, the slice for mixed reality, multimedia, entertainment, video, etc. And of course, the slice of massive IoT. I want to emphasize that for 5G, massive machine-type communication was one of the edge of the triangle, and we didn't saw anything. I mentioned in the previous slide RedCap, we almost see nothing with the directly 5G to the embedded system. So this is something that, of course, was not in favor of the understanding of the technology and on the deployment of the technology. Since if you don't see something working for real, people prefer to use unlicensed technologies in alternative of the one that we are standardizing with times of 10 years from 4G to 5G, 10 years from 5G to the 6G for consensus, for the bands, for the standardization, regulation, etc. So what is, in my opinion, very relevant? It is open, programmable. Those are virtualized functions. And some of the function that in the past were model-based will be now data-driven, and this will have a more robustness. They will give more robustness to our infrastructure with autonomous and self-healing capabilities. So I think that a challenging environment will be the one of tactile internet. Professor Ongwei asked me, please say something about the experiences of your technical group. And in our technical committee, we were quite active even in standardization. You can understand that with your action, you send usually some position, velocity information to the robot at the peripheral part. And from there, usually you have vision and you have a feedback, force feedback that you have to translate even at the leader, at the actuator, and you have to need to have back some feedback information. You can easily understand the stability problems that are behind this class of new function and new services. The definition of the domain is quite complicated. A network or network of networks for remote accessing, perceiving, manipulating, or controlling real or virtual objects or processes in perceived real time by humans or machine. It is the context of internet-based application to provide remote physical interaction, networked control of highly dynamical process, such as the one related to the communication of touch experiences, okay? That will augment for sure our world of reality with respect to just images or sounds. So nevertheless, I want to tell you what we have done in this domain. Again, I want to emphasize the most advanced type of processing is real-time control. And we have a lot of real-time control within ORAN, within the inner function of the network, but even when you are realizing some new services that involve actuators and sensor that works together under the orchestration of some intelligent component that, of course, needs to operate often in real time or near real time. So I want to tell you, we don't have time to enter the detail, but I want to tell you an example of the digital transformation, the switch that I was mentioning. For instance, this is a bike that is realized by a company here in Tuscany, close to Pisa, that is named Piaggio. It's a three-wheel vehicle. And you notice we want to use adaptive fluidodynamics that was used in the past for planes, even for this type of vehicles. So you have actuators that can have a variable geometry that can be allocated with respect to some measurement, some sensing that you can do on the vehicle itself. So you notice the transformation, the ICT transformation, which is the idea behind. The idea behind is, if I can measure the situation awareness of the vehicle, I could optimize some of these variable geometry part. I want to spend some words on the difference within digital twins and simulators. Digital twins are real-time, bidirectional digital counterpart. This means that they are not only receiving data from the physical world, but they can also influence the physical world, okay? So they are a digital counterpart running in the same time, in real time. The simulation is usually offline, and particularly you do this to carry out some offline what-if analysis that can be very useful. For instance, for the optimization, you analyze some parameter, you understand which is the best condition, and you can do for a discrete set of cases your fantastic optimization. Here is carried out thanks to computer fluidodynamics, a model that runs on supercomputer. You know that is a typical application of high performance computing, the fluidodynamics, and there you have the optimization. So we don't have any digital twin here. we used a model of the bikes to find out the best allocation of variable geometry thanks to the use of high-performance computer. So you analyze a discrete set of possibilities of your situation, or the way you are driving, and depending on what you want to optimize, you can optimize performances, you can optimize comfort, you can optimize safety. So it depends on the target that you have. You can have a knowledge-based that is, as I told you, discrete, only a limited number of cases, but then you have to interpolate in real time from what you are measuring the allocation of these resources to provide the best possible safety, the best possible performances, the best possible comfort in some cases. Okay, so here is a typical situation where you have the sensor that are tactile sensor, since they want to act as a sort of electronic skin on the bike, and we didn't reach this solution. We used a discrete sensor, but the basic idea is that on the bike you measure the field of pressure on some part of the vehicle, and then from this knowledge, knowing the optimization, you allocate in real time your variable geometry parts to provide the best performance. Sorry, we will have other opportunity to speak about tactile application and what we have done in this domain. In the field of agriculture, we applied in cooperation with the DISA department of the University of Pisa, and particularly Professor Luca Incroci, this idea of force feedback to the analysis of the ripeness of tomatoes. And you see here the different levels of maturity of the fruit, that a machine such as this one, we have a company, Kubi Robotics, that is acting very close to us, producing these robot hands. It has a single motor to close the hand. It's a very, very interesting solution. And from the force feedback of this, we correlated the tomato ripeness. And we also analyze, and we have a data set of RGB data, bioimpedance, and the force feedback for all the tomatoes that you see there in this picture. So it was a very interesting initial experiences with our colleagues of the Department of Agriculture, Food and Environment of my university. And you know that there is a fantastic automation behind the development of this cloud continuum that we have in mind also for agriculture. I put this picture where even for the kids, we present some experience where without writing one single line of code, you can use all the chain that you see here, Arduino devices, communication to the cloud, even the dashboard on your smartphone without writing a single line of code. But of course, we know very well that, as I told you, there is no one size fits all. There is no the generalist solution. There is no only the cloud solution from the gross market where you have the machine learning tools and you apply them to every case. It's not one size fits all, but you have to spend a lot of time on data cleaning, dimensionality reduction, sampling data, analyzing outliers, data detection, data transformation in some cases. So every single domain requires a lot of activity in that sense and a lot of specialization. Here again, I put just 2 slides to emphasize that we are working closely with our Department of Agriculture, Food and Environment to study the impacts of climate change. These greenhouses divided in 3 parts to study the effect of the different temperatures. They are isolated, of course, not so like in this picture, but nevertheless, we have colleagues such as Professor Incroci on this growing of the tomatoes and other type of plants. We have collaboration with the Professor Landi with the control of the lighting, the collaboration with Professor Cotrozzi in the hyperspectral camera collection of images for the analysis of the growing of this plant, and under the coordination of Professor Gianluca Brunori, we are also trying to understand better the impact of this solution in the development of rural communities and of the agricultural sector. He was the leader in Europe of the ZIRA project that was one of the most relevant one in this type of analysis. And of course, we want to provide a 5G in a box in this environment, an open source solution. In this case was provided by a company in Barcelona that is named Neutron. This is the 5G Nomad. But nevertheless, the point is we want to provide a platform with that idea of slicing, that idea not starting from scratch every time that you want to provide a new service on your infrastructure. So it is the Agritech, the National Center for Technology in Agriculture, that help us in this effort. And another effort arrives, as other support arrive from this spoke tree of the EINS project, that is an ecosystem of innovation in Sardinia, where we use impressive smart cameras with the LiDAR, with the radar integrated with different cameras to monitor ships. And to monitor ships, we want to, for instance, having some automation in understanding anomaly detection in the behavior of the ships, and for instance, mates, counting the mates for us, it's very relevant, and we add the edge computing and satellite communication in this environment. Again, I want to present only one specific case, but it was a great opportunity for us also to explain where we are involved, and particularly this is a collaboration with the veterinary medicine department of University of Sassari with Professor Fiammetta Berlinguer. So what I want to show you in more detail is the case of WatchEdge, that is a project in the framework of the Restart program, 116 million euros for all universities in Italy that are working together in 32 different projects. WatchEdge is one of them, and it is a wide area, agile, and fine network architecture for AI surveillance processing at the edge. You notice the emphasis of AI and edge computing. It is part of one of the spoke. All these programs has this hub and spoke structure, and one of the spokes that is on intelligent and autonomous system. It is coordinated by Politecnico of Milano, Professor Guido Maier, and there are other 3 universities working with Milano that are Catania, Pisa, and Milano, and the other university, Bicocca. Then we have 3 companies, Italtel, Nextworks, that I mentioned before, even for the edge computer, and Sensor ID, that was another provider of smart cameras. And we have a national center of CNIT that is specialized in radar and surveillance. What we want to cover? We want to start from a real problem. And in this case, our real problem is the presence of ungulates in our territory. Wild boar, deers are terrible, difficult to manage in our territory. They produce vehicular collision, agricultural losses. Professor Brunori often says that after bureaucracy, this is the most terrible problem for agriculture in our region. And it also they also spread infections, not to humans, but in this case to pig, for instance, with this African swine fever. And they have a terrible impact on biodiversity, since when you have too many of those animals, it is terrible for the vegetation to survive, okay? Just to give you an example, this is the average in Europe. This is the situation in Tuscany, okay? It is impressive. And those data are not very much updated. So we need to find a way to know which is the situation. Of course, we could have in mind some countermeasure for the control of the animals. I want to tell you that in Tuscany, all these chemical, acoustic, ultrasounds, electrified fences are not working very much. All the main wine producer, they use metal fences to, to avoid these animals to enter the vineyards. And you can easily understand the terrible environmental impact of those solutions. So, of course, if you could have another alternative solution, you need a monitoring system to check the effectiveness of this solution. And of course, you can understand that this is something that will involve the participation of some ambientalists or public administration decision makers, hunting community, farmers. All these are usually fighting together, but nevertheless, they are very much interested in finding a solution for the control. Here it's an example of how you can move some of the animals from one place to another. Of course, an alternative possibility is to shut some of them and kill some of the animals to reduce their number. Restart has also a challenge that is named digitizing the environment for a more sustainable world. And there are 13 projects among the 32 of the Restart program that are in some way related to this grand challenge that I'm mentioning here. So the traditional approach, again, I like very much the transformation, what a technology can transform, not only improve. The traditional approach is inviting volunteers to recognize some of the animals, the ages of the animals, and even the sex of the animals. And, most of them are not expert, and they are recruited a couple of times during the year, and particularly at sunset and dawn. And there, it's very difficult to have quality in this type of analysis. The alternative can be to use trail cameras, but again, you have some fixed position of the trail cameras where you have to go there often to change the SD cards or even the batteries. And the volunteers here are usually biology PhD students or something like this that are helpful for this kind of campaign. We want to transform this situation, and in the framework of the Watch Edge project, we had in mind this concept of island, of separated autonomous actors that has a territory under its own control. And you notice the islands are equipped with the smart cameras, radar, drones, and edge computing. In our case, we provide also a 5G in a box edge computer that is in some way an evolution of the concept of the cloud, that is usually also provided in a container. You can have edge computing in a box, and you can have 5G in a box. You notice also one of the very relevant functional aspect of the Watch Edge, that is the possibility of using SD-WAN for the interconnection of the island. The island can cooperate, for instance, for federated learning, that of course you can imagine that we want to have embedded AI cameras that are able to count the animal, to carry out object detection, to provide some of the activities that in the past were provided by these volunteers. So we have a very interesting environment since we have a national park, a regional park close to our university. My department is here in the town of Pisa, very close to the sea. And this is the park that is within two rivers, Serchio and Arno rivers. And we have even our the green data center of the University of Pisa that is within the park. So we have this cloud continuum that is possible to deploy here for this type of action that was totally under the control of the group, of the research group at the University of Pisa. So we are here describing one of the islands, the one that is named Pineta, one of the islands that is totally under the control of University of Pisa. The first action that we carry out was the correct building of a balanced data set of independent images. I want to show you the case of Serengeti, that is a public domain data set with the largest number of animals all over the world. You can easily understand how this is unbalanced. Okay, there are very nice experiences of citizen scientists, but you know, when you want to use a data set for the image classification, object detection, you need top quality data set. You know, garbage in, garbage out. So it is true that everyone knows that it's possible to recognize the images, to classify the animals present in the images in the backstage of the cloud, but doing this directly on the camera in this hardware accelerated embedded system, it is something that needs a lot of attention starting from the dataset itself that of course was constructed in cooperation with experts. You see here 5 classes, wolf, wild boar, and different type of fallow deers, but you know, some of the data of course was used for the training, then for the validation, and final for the testing. Again, we had to compare, this was Awidur Rahman, that is a PhD student of us that carried out a lot of activities in this domain, and also comparing, as you see here, different type of neural networks. We used YOLO, and of course, as you can imagine, the training is done offline in a cluster of computer in the data center, usually thanks to the availability of the NVIDIA GPUs, and then you have your trained neural network, and you can consider some KPI to decide which is the best one for your embedded solution. Now you have to take it and squeeze it inside the smart camera. The smart camera was realized together with this fantastic network infrastructure by these two guys, Elvisa Marcu, that was a former student of computer science and networking, and Sanil Matthew, that was a postdoc of University of Parma. And you notice that we have here Starlink satellite for the backhauling of the edge computer, a sub-6 gigahertz 5.5 gigahertz point-to-point radio link, and we use in the forest Halo, since Wi-Fi, LoRaWAN, even LoRaWAN, although it's impressive low bitrate, is not able to work correctly in this very hard environment. So we have autonomous devices. These are solar energy harvesting cameras, and we have gateways here that are totally autonomous from the energetic point of view, and we could even have the edge computer totally autonomous. So this was something that for us was the integration of computing and communication with heterogeneous networks in an environment that is in the middle of nowhere. We are nowhere. We have, as you can understand, no coverage of the operators. We have no 4G, no 5G, but they don't want us to switch on 5G, our private 5G solution, since in Italy, the operators altogether, they spend 6.5 billion euros for the licenses. So they spend half of the money that they could invest in the infrastructure in a tax. And for that reason, we don't have 5G in Italy, okay? We have the 5G radio, but we have 4G core. So it's a non-standalone solution. And those solutions, the one that we are providing are of course standalone solution, capable of slicing, capable of allocating quality of service, but we didn't use that. We moved back to unlicensed technologies since they didn't allow us to switch on the devices. And you notice here the characteristic of the smart cameras. Inside we have NVIDIA Jetson Nano or in Nano, and we notice that we have the light for the night vision in infrared. We have a specific camera for the night vision. We have the MPPT controller of the solar panel to charge the batteries in the proper way. We also measure temperature, we will see in a while, and humidity on each of the cameras, and we have halo communication, 802.11 AH for low power 868 megahertz communication in the forest. But you notice if you give us the possibility to switch on our 5G, we could connect easily our camera with the SIM card, the private SIM card that we can use in this 5G router that we can interconnect to a cluster of cameras. Nevertheless, I don't enter, you can imagine that from the passive infrared sensor, you have the shooting of the camera, the acquisition of the images, then you have an MQTT communication with the edge computer to collect all the images that now are even moved to the central green data center of the University of Pisa that is on premises, not far away as the data center of Google, Microsoft, or Amazon Web Services that we could have also in Italy, but very far away from us. And this could be very helpful also for the interaction with some actuator for the repulsion of the animals. You notice here how the time constraints aspect can arrive sooner or later as a requirement if you have to detect and act. So this control loop, of course, would be something that in the future can be provided, for instance, for ultrasound repeller. So far, we had only the monitoring part, the part of the satellite communication was covered by PhD student Luca Borgianni that here is in Stanford University when he spent 6 months and speaking with the satellites to have the best communication possible. But nevertheless, we have the satellite communication here to our edge computer. Then we have the 5.5 gigahertz point-to-point radio link. We have solar panel for the gateway and for the radio links, and then we have 802.11 AH halo communication to the cameras. It's interesting, we could have these heat maps from the data that we collect, we can construct some dashboard for the detection of animals. Of course, you will need a regular grid of cameras in the territory. We have just a few of them now, but you notice also the possibility of extracting knowledge even just for timing, from the synchronization of the devices. Some of the animals, of course, is evident here, they come out during the daylight. Some other, they come out only during nighttime. Are the same. Some of them exit only if there are specific temperature. Other are more flexible with respect to the temperature. So you notice this the behavior can be extracted by the correlation of the data that we extract from our cameras. This is an example of our dashboard. You notice we can measure, of course, we can count the different animals, but we measure every possible aspect on our devices: power consumption, allocation of resources, such as GPU, temperature. We have 4 types of temperature: the board temperature, the box temperature, and the external temperature. And with the board temperature, we have GPU and CPU temperature. So all these data for us is something that is very, very relevant to correlate with the performances, with what we measure in terms, for instance, of the quality of the radio link, the point-to-point radio link. Notice the temperature where we were working during one of the most terrible weeks all over the year in our territory due to the heat wave that we had in that period. It was really, everything was working, although the terrible temperature that we had. The external temperature was on the order of 38.8 Celsius degrees. And again, the power consumption. And we notice, for instance, here, you can notice that the GPU are too much active. The two GPUs of the two camera 1 and camera 2, they are very, very often active. Since something moves, and the peer is a very stupid device with respect to the triggering the camera. So the camera switch on, there is nothing in the scene, there is no classification, nothing to be sent, but you spent around 25 watts for this action of the GPUs. We in some way want to have more processing than communication, but we spend a lot of energy for the processing if we don't find more efficient way to trigger the camera for the image acquisition. And this is one of the lessons that we learned from the practical experience, and there are many of them, of course. Again, this is the watt generated by our panels, the maximum watt generated by our panel. One of the panel is very strong, the one that is powering the gateway. So we had this analysis also for the power consumption, and also for the needs, for the request that we have at the level of the Halo 802.11 AH wireless communication. You notice that we typically go under 1 megabit per second. And so it was possible to reach even 3.5, 4 megabit per second, but on average, you notice we stay much lower than that speed. So again, from the practical experiences, we analyzed the requests, the requirements of our design of the network. And of course, the dream is to work on this idea of distributing the processing that is due to the artificial intelligence processing. And here we have Edoardo Colli, that is another former student of computer science and networking, where we are trying to split the YOLO pipeline to understand what can be done here on the embedded system, what can be offloaded to the edge server. And of course, we have alternative possible splitting of our neural networks step by step. Although federated learning, I already mentioned the idea of having the same type of data set in all the island, the same type of neural network in all the island, you can have this federated learning approach that can give you the possibility to have a win-win situation, sharing your models, not the data, to a centralized actor. And that could be the data center of the University of Pisa orchestrating the interaction with the different islands. Of course, we would like to use a RedCap to see if we can move IoT, the massive machine-type communication in the field of IoT. No one saw very much in that direction, but you notice we have also the cooperation with the drones. This is University of Catania that is working a lot in this domain, but I want to emphasize that this was an opportunity to show that if you have a platform, you start from the solution of a problem and you can move to the solution of another problem, such as the detection of fires. We have 2 helicopters in the park ready to fly to detect in case of detection of fire. And you notice that here we can use our cameras. Of course, if we have slicing, it's a totally different domain. It's a totally different data set. It's a totally different training. So everything has to be specialized in this domain too. So going to the conclusion, I want to emphasize that something surprising happened from these practical experiences. We noticed that the guards use ultra expensive binoculars, thermal binoculars, such as the one that is shown in this picture, to see the situation, to see the scene, to see the concept that is behind the observation of that portion of the territory. This stimulated us in something that was a breakthrough in the transformation of telecommunication, that is semantic communication. You all know about the technical problem, the Shannon limit, when you transfer bit and you don't care about the meaning that is behind the transfer of that information. You can easily understand that if we have the possibility to detect the animals, we could send just a few bytes with the names and number of the animals, and at the edge, we can reconstruct with the generative AI the scene. I want to show you a couple of examples that we obtained as a very, very first initial experiments. This is what our smart camera collected. It holds, the shaping of the background, of course, of the presence of the whiteboard, and this is what the generative AI reconstructed. So it's incredible. You have the same concept. You have something that is very similar to what the guards want to obtain. So knowing the real needs, knowing the problem, you can provide a very interesting solution, even from the telecommunication point of view. I want to show also the semantic error. This is fantastic. You classify fall of deals, and the generative AI will produce a fall of deals instead of whiteboards. But this is for us very much stimulating, and we hope to go on and to cooperate with you in this type of domain that is, in my opinion, very relevant for Italy, Europe, but I think also worldwide. Thank you very much for your kind attention.
Thanks a lot, Professor Stefano. That's a very exciting overview of many projects of sorts. So I think we have maybe 5 to 10 minutes for general Q&A. Maybe folks have questions, you can either unmute yourself and ask question, or you can type, then we can help share the question with Professor Stefano. Maybe just to kick this off, maybe I have 2 just quick, simple clarification questions. I guess in the Watch Edge project, right, we used the 5.5 gigahertz point-to-point link. So what's the distance for that? Like how much capacity were we getting from that study?
Okay. very good point. The distance was around 200 meters,
Uh-huh.
and this is one of the components of our network infrastructure
Mm-hmm.
that can be configured in several different ways in terms of the bandwidth you are allocating,
Mm-hmm.
the coding scheme that you use, the modulation, etc. We reach at the gateway 300 megabit per second to the gateway to one of the station of Starlink. So we have an impressive high throughput in even at the gateway position. Okay,
Uh-huh.
that for us it was not in our request, but if I switch on 5G in a box,
Mm-hmm.
could I reach 300 megabit per second?
Mm-hmm.
You know, 5G was promising 20 gigabit per second to the
Yeah.
end user, 20 gigabit per second. You have this fantastic software-based open source solution. If you ask the guys, it depends on the codes that you are using. It depends on the quality, the type of server, the type of switch, bam, bam, bam. But okay, I bought something that cost around 50,000 US dollar. What can I reach? Probably, Stefano, 50 megabit per second. So this is something that is not possible. You understand my point? When we do the comparison with the,
Mm-hmm.
let's say, legacy solution and license solution, we need to be better. To be better in terms of performances for sure, and in terms of more of functionalities. So this point, your question is very relevant. If I switch on 5G, I'm not sure to reach 300 megabit per second.
Mm-hmm. Right, right. Yeah, so that just highlights some of the importance of edge processing, right? Instead of transmitting all the raw data
Yes.
to the cloud. Maybe a related question, on the 802.11ah, right? Looks like you were able to run it at a low power mode, and given the IoT sensor doesn't need a lot of capacity. Just curious, have we done any like range measurement? For example, how far can the 802.11ah signal go? Like,
Yeah,
how?
yeah,
Yeah.
yes. You have to consider a way that we are in the forest,
Yeah.
and we reach over 300 meters. Over
Okay.
300 meters. That was impressive. We had some publication in the past
Yeah.
on LoRaWAN. In that domain, the trees are full of water. Even LoRaWAN is not able to work. Okay, so we were very much impressed by the robustness of 802.11ah in that environment, and practically we arrived to 300 meters, a little more than 300 meters. In that context, the forest, I want to emphasize this point. We are
Yeah.
going inside, with trees, pine trees, full of waters.
Right. Yeah, great. Yeah, that's good to know. Yeah. All right. Any other sorts of questions folks may have? So this is a chance. I do have a long list, but I think I wanna don't wanna monopolize the opportunity here.
You are carrying out in Ara Wireless one of the most advanced, probably the most advanced trial in wireless in US, and I think that you are using even customized solution for wireless communication with super high bandwidth and probably super high frequency with respect to the one that we used there.
Yeah.
Do you have any comments on the comparison with legacy solutions such as the one? For us, it was very relevant to know the consumption. For instance, the power, the processing is 25 watts peaks, I mentioned.
Right.
The communication is 3 watts, nothing with respect. So we are in some way bartain the communication with processing, but we spend a lot more. Okay, so Okay, I don't know if in your experiences you had the opportunity to have computing and communication together, such as in this framework that for us was
Right,
the challenge.
right. Yeah, so I think yeah, those are very important decisions, right? I think communication, no matter how advanced, how much capacity we have, you would find there's always applications that can demand more capacity, right? For example, even
Interesting.
yeah, I think depending on scenarios, I think probably the way going back to your comment about solving real problems, right? I think the kind of for the kind of sensors and use cases we look at in Era so far has have a little bit more focus on those use cases that need a lot of capacity compared to the low rate IoT sensing, right? I think, for example, data intensive real time communications would be what we kind of try to target within that context for the backhaul, right? We also use the NeoSatcom, but also we do focus more on the terrestrial so far. On the terrestrial part, we look at both middle mile and last mile, right? The middle mile would be like the point-to-point link that's used there, except that we are looking at more of the high capacity links. For example, with the free space optical solution, we would be able to get up to tens of gig or 100 plus gig. With the millimeter wave, we're kind of using the free space optical at 194 terahertz and then 80 gigahertz and 11 gigahertz. For the 80 and 11 gigahertz, they also provide a few gig of middle mile kind of capacity. For the last mile, that's where we gonna also focus on MIMO high capacity communication platforms at across the different band, like low band, high band, and mid band. They typically can all provide up to 100 meg plus capacity. But still, now if you look at some of the ag vehicles, right, they could have tens of cameras. So if you look at the raw data, that could be like we're talking about tens of gig, like 16 plus 10 plus gig BPS. Right? So basically that just means that you need to do a lot of local processing before you send anything even to the edge or the different to the cloud, right? You don't want to actually just send all the raw data to the cloud. Yeah. So I think some of the paradigms that's captured in some of the project in PISA, I think that's kind of similar, even though the specific platforms and use cases, there's a little bit diversity, right? I think in terms of the kind of sensors and use cases we use there. Yeah.
Yeah, so of course you can imagine that with respect to cameras, you notice that when I mentioned the greenhouse case, we have hyperspectral camera, and we don't know so far which will be the throughput. That depends, of course, on the number of frequencies that you use, of the resolution that you use, etc., etc. But nevertheless, there too, there will be a huge request for throughput. And with respect to, we didn't want to move the raw data. This was exactly what we don't want to do, but it's nice for the comparison.
Yeah.
So this is something that is for sure.
I thought, by the way, so all the platforms in Era can be accessed remotely. I think if any of your colleagues, your students, team members would like to try, or even your colleagues in the network of university associations, CNIT, right? You are welcome to try out. I do have one question. Then, if so you mentioned the scenario for the ship, right? Ship. I'm curious, like in Italy or Europe in general, like how would I assume there are probably these open ranches, right? Like in US, this ranch land tends to be very big for professional ranchers, right? Like hundreds or thousands of acres. That, the size terrain does impact how you would deploy the network, right? I'm curious, like in Italy, for example, do we have a lot of kind of open ranches for livestock farming, or typically what's the size of such farms? Do we know? Like,
Very, very small. It's incredible. The economy of Italy is almost based on small and medium enterprises. Although
aha,
we are the fifth country all over the world in terms
mm,
of export, the size of our companies is very, very limited. And this is even worse in the case of farming and agriculture.
mm,
Consider that usually 3-4 hectares, 100 meter per 100 meters, is
ah,
the territory covered by one company in Italy. It is
ah,
impressive, since I know that you
aha,
call small one company with the 50 hectares
ah,
or something like this in your territory. So
I see.
on the contrary, it's very, very rare. Consider that in 2010, that was probably the crisis there in that period, but there were only 3,000 companies in Italy with more than 200 employees. So
Mm,
a very limited number of employees,
mm,
200, but we had only 3,000. And different from Germany, we don't have large enterprises. We have
mm,
mainly very small and
mm.
medium enterprises.
Okay.
And there, the technologies are probably more fast to enter. You understand my point?
Right, right,
But we have to convince them,
right.
since for them, the issue of the return of the investment is terrible
Mm,
relevant, right, with
mm,
respect to what happens to the big companies that can, of course, try whatever they like.
right, right, right. Yeah, yeah, yeah. Good to know. Um, all right. So, any other, maybe before we close this part, any other sorts of questions may have? Last chance. Okay. So Stefano, if you have, I know it's already late there, but if you may have another like